Hello, in this lesson, I'm going to go over classwork practice for 4.4, 4.5, and I'm also going to address some common mistake that I see students making during class. So here's go. So in 4.4, 4.5, we talk about polygons and exterior angles of triangles and triangles. So one of the problems in the practice is solving for x in number 1 right here below. So here, before I go over this question, let's just discuss what exterior angle is in a triangle. So if I give you a triangle, I don't care what that is, right? It's a triangle, I call it ABC. So to make an exterior angle, let me write a little better. Exterior angle, I can extend any side of the triangle. So I'm going to extend, I could extend this way if I want, right? I can extend this way. I could extend it this way, right? Extend it. So you can extend one side of the triangle, of this size of a triangle to get the exterior angles. So let's focus on one of them. Let's say I have, this is the triangle ABC. Let me label them better. I'm going to number them just so easy for discussion. Let's say this is angle 1. Let me use a different color, angle 1. Let's make this angle 2. Let's make this angle 3. This is angle 4. So angle 4 is the exterior angle for triangle ABC. So the exterior angle theorem states that the exterior angle, which is this for here, the measure of this angle is equal to sum of two non-adjacent angles. So angle 1 and angle 2 are non-adjacent angles. So measurement angle 4 is equal to measurement angle 1 plus measurement angle 2. So that's a relationship for exterior angles here. So by using this same principle here, let's look at what's given here. So we have, this is an exterior angle right here, and these are two non-adjacent interior angles. So to solve for this, can you use the principle? So I say, well, exterior angle is sum of two non-adjacent angles. So I say, well, exterior angle in this case here is 3x minus 10. And this is equal to non-adjacent angles. One of them is 25, and the other one is x plus 15. So exterior angle equals sum of two non-adjacent angles. So add them up. So now it's just a matter of solving. And let me solve for this. I notice I'm solving common mistake in solving as well. So I say 25 plus 15 is going to give me 40. So x plus 40 here. On the left hand side, 3x minus 10. So in solving equations, generally speaking, whatever you do to one side of the equation, you need to make sure you do to the other side as well. Say, for example, if I add 10 to both sides of the equation, so I'm going to add 10 here, that tells me I need to add 10 on the right hand side as well. Okay, if I want to subtract x to the here, I can subtract it. I can subtract x on the other side. So now it's solved. Combine like terms here. So negative 10, positive 10, when add them becomes 0. So this is a 0 here. So it cancels, becomes 0. This is another 0. So on the left hand side, I have 3x plus a negative x, which is just 2x. So I have 2x on the left. And on the right hand side, I have 40 plus 10 give me 50. Now divide both sides by 2, I got 25. So x equal to 25. We just saw using exterior angles here. So that's question 1. Now let's look at question 2. Question 2 is a proof question. I asked you to prove that angle 1, angle 2 here is equal to sum measurement angle 3 plus measurement angle 4. I see several approaches for students do in class. So I'm going to do one of the approach where I see a lot of students make mistakes. So one mistake I see students talking about is a justification for supplementary, and so let's just make a note on the right hand side before we make the proof. So note the mistake I see pretty common, you see, so note that. So let's say I tell you that I have an angle. Let's say this angle looks like this. So it's a 90-degree angle. I'm going to make it perpendicular, and I'm going to make a segment here. This is a segment right there. Let's make it better. Okay, let me just draw it. So look like this. Let's say this is angle 1, angle 2. Let's say make this A, this point is A, this point is B, this point is C, this point is D. And if I tell you that, if I'm telling you angle 1, angle, by looking at the picture here, if I know this is perpendicular, right? Say given, you're given that AB is perpendicular to BC. So you're given that and say, well, and now I'm going to label this one angle 1, angle 2. You can say that, well, this given, I can say that angle 1 plus angle 2 is going to be complementary. Well, what make it complementary? We'll say here, I'm not talking about perpendicular line. It makes me angle ABC equal to 90, but I'm talking about two angles here. So I could say, one of my reasons, I could say measurement angle 1, or I could say measurement ABD plus measurement angle DBC. Here, going to give me 90. So let me write a statement. On your statement side, I will see this measurement angle 1. Make it easy, I'm going to use number. Measurement angle 2 is going to give me the big angle, which is 90 degrees. Let me write justification here. So 1, I will see that ABC measurement angle ABC is equal to 90, right? So I will see your statement, your reason on the right hand side. And the reason part is if two lines are perpendicular, the angle formed is a right angle, or it's a 90-degree angle. So if the two lines are perpendicular, be given perpendicular. So two lines perpendicular, then they meet to form 90-degree angles. They meet to form right angles, or right angles measures 90, form 90-degree angles. So what type of justification for it? Well, what if I want to say angle 1 plus angle 2? Let me use this one statement. Say number 2, I want to say measurement angle 1 plus measurement angle 2 equal to 90. Well, we know that measurement angle 1 plus measurement angle 2 is going to give me the big angle first, because this is by angle addition postulate. So I'll say, well, that's measurement angle ABC. And so number 2 here, that will be angle addition postulate, the reason for it, because two smaller angle here add up to the big one. So addition postulate. Okay, number 3 here, well, if I want to say angle 1 plus angle 2 give me 90, what is the reason for here? So measurement angle 1 plus measurement angle 2 give me 90. Well, by looking at this, I see that measurement angle ABC is 90. I have measurement angle BC over here. I'm basically rewriting the same expression, but replacing with equivalent form. So 90 is, say, measurement BC is 90. So I did a substitution here. So the reason is substitution, not angle addition postulate here. So substitution. Okay, so that would be the reason for it. So that's one of the common mistakes I see in the general proof involving 90-degree angle and substitution. Now, I'm going to show you another one where I see also a common mistake that I see from students. So let's talk about supplementary. Okay, so let me draw two angles. Let's say I have angle, okay, and I'm going to draw another one over here. Okay, I can make this, label this one again to easy discussion. A, B, C, D. I can make, again, for easy, I like to number them. Let's just use the name of the angle here. 1, 2, okay. Angle 1, angle 2 is 180. A lot of you can tell me, yep, by looking at the picture, I know angle 1 is angle 2, gonna give me 180, but what is the reason for it? So if I say measurement angle 1, in this case, I'm gonna use the letter ABC plus measurement angle DBC is gonna give me 180 degree. But what is the reason here? I see a lot of reasoning say, oh, this one is supplementary. Well, what are you using? What exactly make it supplementary? So in class, one of our theorem states that if the opposite rays or the exterior sides of two adjacent angles form a straight line, then the angles are supplementary. So what it's saying here, this is the opposite rays, one of the right here, or non-adjacent exterior side. So this is the exterior side of this angle, of angle 1, and this is the exterior side of angle 2. Well, what this theorem saying here is that if the exterior sides of two adjacent angles form a straight line, then the angles are supplementary. So let me write down the reason. So if the exterior side of two adjacent angles form a straight line, And then the angles are supplementary. The angles are supplementaries. Okay, so that will be the justification for why this is 180. Now I think I see the confusion on adjacent angles. Adjacent angle is basically an angle where two angles they share a one common vertex and common side. So I can draw adjacent angle where it's not supplementary. Say for example, this is the adjacent angle 1, 2 here. So I can also draw another one. Say now this angle here is also so let's say 1, 2 here. 1, 2 is adjacent, 2, 3 is adjacent, and I can 4 here. 4, 3 is adjacent. So adjacent angle doesn't mean they bisect each other, had nothing to bisecting here. Adjacent angle means they share a common vertex right here and one common side. That's what adjacent angles means. So be careful when you write justification for that. We've been using this one in class quite often, so please do not confuse them. Now I'm going to use this. We're just going to do the proof on the right hand side over here. So for this proof, as you are given a quadrilateral QRST here, T A Q. So with exterior angles R and T, one way to do this proof here is to look at the relationship of writing equations involving I see equation involving 1 and 2, 3, 4 here. I can just write equation about them. So I can label some names I'm going to add. So I see there's 1, 2, 3, 4. I'm going to make this 5 and 6. I can make, add names. So this is 6. So instead of saying angle QRS, I could say angle 5. So just for easy to plan and work. But make sure you actually label them before you use them in your proof. Another common mistake I see in your homework, students' homeworks are the student were using, oh, angle 5, angle 6, but there's no picture drawn. There's no, the name wasn't given in the given. So you're just using something that wasn't even in the direction and you didn't label them. So that's incorrect. You need to make sure you label them before you use them in your proof. So now let's just plan a proof before we do it. So at this point, I encourage you to pause the video and then make a plan yourself. Okay? All right, I hope you pass and you make it. So now let's do it together. So plan. Okay. Again, before you do any proof, it's always good to make a plan. So knowing what you want it. Again, I see what I wanted involving equations of involving angles 1, 2, 3, 4. So that means I want to write equations involve 1, 2, 3, 4. So one equation I can write here is I'm giving a quadrilateral. Right, quadrilateral. So in class we discussed the sum of quadrilaterals is sum of interior angles in a quadrilateral is 360. So one equation I can write is I say, well, 3, 4, 5, 6 is going to give me 360. So I could say measurement. Be very careful with your notation here. Talk about the measure of the angle. So measurement angle of 3 plus measurement angle 4 plus measurement angle 5 plus measurement angle 6. Here it gives me 360 because the measure of interior angles of in a quadrilateral is 360. That's the theorem. Now I've done with this pair here. I'm going to look using notice the right equation involving 3 and 4, which is what I wanted. Now I want to write equations involve 1 and 2. Let's say here. So notice that I have a pair, right? I have 6 and 2 here, going to give me 180. 1 and 5 give me 180 here. Again, this is the reason they form 180 because they are exterior sides of adjacent angle from a straight line. Therefore, the angles are supplementary, which is measured 180. So here I can write two equations essentially. So I could say, equation 2, I could say, well, measurement angle 1 plus measurement angle 5 gonna give me 180. Okay, I could say equation 3, I could say, well, measurement angle 2 plus measurement angle 6 gonna give me 180. Now I have three equations involving the have the angles that I want and measure of things I want. Now I look at what I have here. Notice that I have a 360 over here. This is a 360. So if I have a 360 somewhere, I can substitute a 360 and potentially make this on one side of my equation. And notice equation 2 and 3 here, I have 180 and 180. Well, I have two equations in algebra class. We say, well, we can add two equations to form another equation. So we could do that. So if I add equation 2 and equation 3, notice the right hand side, I'm going to get 360, which is exactly what I have on the first equation here. So let's do it. So adding the two equations here, I'm going to get equation measurement angle 1 plus measurement angle 2 plus measurement angle 5 plus measurement angle 6, and that is going to give me 360. Okay, I'm adding these two equations here to get this one. I'm adding both sides here. So this addition property equality, that will be justification. So equation 4, notice that now I have 360 on the right hand side as well. Now I could just set, notice what I wanted. Again, when I make plan, I always want to look at what I wanted. Look at what you wanted here. I have angle 1, angle 2 on the left hand side. So I'm going to write this equation on the left hand side, and then I'm going to make equation 4 on the left, equation 1, this part here, on the right. So I'm going to let this part here equal to this part. Okay, equal to each other. And then notice that both have 5 and 6 on both sides. I could just subtract them to both sides, then I have what I wanted. So that is the plan. Okay, so let's write the proof. Again, make a plan before you do anything else. So step one, I need to have the measure of the interior angles in the quadrilateral to be 360. So I need to note that's an equilateral. So I'm going to write a given. So I say given quadrilateral. Okay, R, S, T, Q with exterior angles at R and T T1 that is given. Okay. Number 2, I'm going to write the sum of the interior angles in the quadrilateral, going to give me 360, which is what I want here. So number 2, I say measurement angle 3 plus measurement angle 4 plus measurement angle 5 plus measurement angle 6, give me 360. And the reason for this one is sum of interior angles of a quadrilateral is 360. So I can just write it, sum of interior angles of a quadrilateral equal to 360. Okay. Again, very specific. I'm talking about interior angles. So number 3, I can just say have my two equations that I wanted. So I'm going to write that the one, look at my plan. Again, like that's not a 1. So I'm going to write it. So 3, I want measurement angle 1 plus measurement angle 5, give me 180. I have measurement angle 2 plus measurement angle 6, also give me 180. Again, adjacent angles, exterior sides of adjacent angle form a straight line. That's what makes them 180 here. So let's write our reasons. So it's if exterior sides of adjacent angle form a straight line, okay, then the angles are supplementary. And let me write, then the sum angles are supplementary. And we know the supplementary is 180, means equal 180 here. So without generosity, I could just set equal 180 on the left there. So now I say, well, I'm going to make another 360 here. So I'm going to write it. So next step, I add the equation in step 3. So number 4, I say if I add measurement angle 1 plus measurement angle 2 plus measurement angle 5 plus measurement angle 6 is going to give me 360. Again, I'm adding these two equation here, add them to give me this one. And I'm adding both sides of the equations here. So when I'm adding things to both sides of the equation, it's just addition property of equality. So addition property of equality. Now I have a 360 is equal to 360 there. So the two equations both equal to 360, therefore they equal to each other. So my next equation, I'm going to do substitution. I say 5 measurement angle 1 plus measurement angle 2 plus measurement angle 5 plus measurement angle 6 is going to be this equation over here. So I'm going to write it measurement angle 3 plus measurement angle 4 plus measurement angle 5 plus measurement angle 6. So I just set them equal to each other because they both equal to 360. So they equal to each other. It's right here. Okay. So now my reason for that one, I'm going to write number 5 over here. I basically substituting. So substitution. Substitution again is important that you tell your reader which one are you substituting. I'm substituting using step 2 and step 4. So I'm going to write it here. I'm using step 2 and step 4. I am supposed equal to 360. I'm substituting them. So substitution. Oh, let me go down here again. I don't know what happened here. Zoom in. Okay. So number 5, we're almost done there. Notice that this equation here, they both have equation angle 5, angle 6 on both sides. So if I subtract measurement angle 5, measurement angle 6 to both sides, then this equation is just get to 1, 2 on the left, 3, 4 on the right, which is exactly what I wanted. So step 6, I have, again, you could just write a note here. This is, you could subtract measurement angle 5, subtract measurement angle 6, and subtract measurement angle 5, subtract measurement angle 6. There, you don't have to write it here, but if it's easier for you to see, you can definitely put a little note on the bottom there. So now I say, well, on the left hand side, I have measurement angle 1 plus measurement angle 2 is equal to measurement angle 3 plus measurement angle 4. And that's exactly what I wanted. So I subtract something to both sides of the equation. So therefore, subtraction property equality. Subtraction property of equality. So I'm done. Okay, so let me zoom in so you see the whole thing again. Okay, so we went over some exterior angles in a triangle. We're also talking about common mistakes that I see students making in class, and then I'm writing a proof of the second practice question in your classwork. Thank you for watching the video. I'll see you next time.